All right, so section 10.2, we are going to actually complete a full hypothesis test, and we are going to do those on population proportions. We are going to first discuss the entire process of the hypothesis test. So let's pretend the politician hires a polling firm to obtain a random sample of 1,000 registered voters in her district and finds that 534 are in favor of the policy. So that means our p-hat, or our sample proportion, is 534 out of 1,000, or 0.534. Do these results suggest that among all registered voters, more than 50% favor the policy? Or is it possible that the true proportion of registered voters who favor the policy is still 0.5? And we just happen to survey a majority in favor of the policy. This is what we are going to be looking at. This is the process of hypothesis testing. What we're trying to do is figure out, would it be unusual to obtain a sample proportion of 0.534 or higher from a population whose proportion is 0.5? What is considered convincing or statistically significant evidence? When observed results are unlikely, under the assumption that the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis. Now, depending on what we are given, it will determine what our level, or where we're going to determine our level of significance here. Do we have enough evidence? What we have to do is we build our probability model. Take our sample proportion. We would verify using the NP, 1 minus P, that it is in fact greater than 10, and that it is a small enough sample in regards to the entire population of the district. So we can use a normal model to estimate our results. Okay. We then would calculate the standard deviation. We would have our mean, our standard deviation, and our test value. The mean was our null hypothesis value, the 0.5. We want to determine if it is more than 0.5. So we would draw our normal curve. Here's our 0.5. Following our standard deviations, and our value in question is 0.534. So that's over here. And we want to know, is this unusual? Is that result unusual? The method that we're going to use is called the p-value approach. So the criteria we're going to use is p-value approach. And what we're using is figuring out the probability of getting that result. How likely it is to obtain our sample proportion of 0.534 given our initial mean and standard deviation. If the sample proportion of 0.534 or higher is unlikely or unusual based on the terms given to us, we then have enough evidence to claim against the null hypothesis. What we're going to do is we're going to use that normal curve. We're going to have our mean, or enter our null hypothesis, and figure out our testing value here. What is the probability of getting the value we got? What we're going to do is we're going to use StatCrunch. We're not going to do this longhand, okay? StatCrunch does all of this for us and is going to spit out an answer here. That value is called the p-value for probability value, which is telling me in about 2 samples, about 2 out of every 100, because if I rounded this, 0.02, 2%, 2 out of 100, would result in the samples we got of 0.534. Because that is considered unusual in terms of basic unusual, smaller than 0.05, we would say we have enough evidence against the statement. So a p-value, again, is the probability of observing the sample statistic we got. Getting that or more extreme than what we got. To say it another way, it's the likelihood or probability that the sample will result in a statistic such as the one obtained if our null hypothesis is still true. If the probability of getting a sample statistic is extreme or more extreme than the one obtained, is smaller under the assumption than the statement in the null hypothesis, we can reject the null hypothesis. Now, this may not make sense until we actually work a full example, so please just bear with me here. The smaller your p-value, the stronger your evidence is. The smaller it is, the smaller the probability, the more unusual the result is that we got from our sample, and the more evidence we have against the null. In any case, no matter what we do, if your p-value is bigger than 0.10, we're not going to reject the null hypothesis. 0.10 is the limit that we're going to look at depending on what we have. We may ask for smaller than that, but we will never go larger than 0.10. We won't be able to do that. If your p-value is between 0.05 and 0.10, there is some evidence against that null hypothesis. If it's between 0.01 and 0.05, we have moderate evidence against the null hypothesis. And if it's between 0.001 and 0.01, strong evidence. And of course, if the p-value is even smaller than that, we have really, really, really strong evidence against the null. You are going to be given your testing value. You're going to be told we're using 0.10 or 0.05 or 0.01. You will be given your limit in each problem that we do. Let's actually go through the steps of testing a proportion. So the first thing you're going to do is create your null and alternative hypotheses. Pick your option, set them up. Proportion is equal to what value, and then what's your alternate? Not equal to, less than, or greater than, and what is that value? You're always going to put a number in there. Step 2, they're going to give you a level of significance. That's the 0.10, 0.05, 0.01. And that is what we are going to use to compare our results as we keep moving forward. We have to make sure, again, it's a simple random sample. We'll check NP, 1 minus P is greater than 10. Again, all the ones I give you are going to do that. So we can just check it off and say, yeah, it works. This will also work. Our sample is going to be no more than 5% of the entire population. So we can just check it off. And then we are going to use StatCrunch to get our p-value. Step 4 is to compare our p-value to our alpha. And if p is less than alpha, we're going to reject our null. And lastly, state the conclusion. We are going to go through, let's see, I've got 1, 2, 3, 4 examples of full hypothesis tests here. Humira is a medication used to treat rheumatoid arthritis. In clinical trials of Humira, 705 subjects diagnosed with RA were administered 40 milligrams of Humira every other week. Of the 705 subjects, 66 reported nausea as a side effect. Okay, so this is what we were told. It is known that the proportion of RA subjects is in similar studies receiving a placebo who report nausea as a side effect is 0.08. So this is what we know. This is our status quo. The sample evidence represents significant evidence that a higher proportion of subjects receiving Humira experience nausea as a side effect from those taking placebo. Use the alpha of 0.05 level of significance. First thing we're going to do is create our hypotheses. And this is our status quo, okay? That is our proportion, 0.08. And we want to then test, is ours higher? Our null is that our proportion equals our status quo value of 0.08. We are testing that it is greater. That is what it asks. Is it a higher proportion in those that are taking this drug? So step one is we do that. Step two, write our level of significance, and we are going to verify it was from randomized experiments. We can test NP times 1 minus P. It is in fact greater. And then our sample size is correct. So anytime this one I say, you guys can just check it off and just say that yes, it works. Because all the questions I give you, it is going to work. Step 3 then is going to StatCrunch and figuring out how the heck we do this. From last chapter, we went through t-stats, proportion stats, and variance stats, depending on what we had. So we have a proportion again, and we have one sample, and we have a summary. What I'm going to enter in here is what my study told me. My study told me that 66 out of 704 got this nausea. Okay, that's what my study said. Sorry, 705, not 704. I want to perform a hypothesis test. So now I'm going to use this one here. After 9 with confidence intervals, we are going to perform a hypothesis test. Our hypothesis is that our proportion is 0.08, and that our alternate is that we are greater than 0.08. So we are going to do two things. We are going to enter your value for your hypothesis as well as the symbol here. And then down here is our significance. So I can click show the critical value, and I'm going to enter my level of significance, which is 0.05. There's your default. And I'm going to click compute. It's going to give me my sample proportion, some other things here. This is the error. This is my z-score for my value, the critical score, and my p-value. My p-value for this test is 0.0913. That is step 3, getting this value here, 0.0913. This was a different fit out, 091. We went one extra place, 3. And what we're going to do is we're going to compare P to alpha. So the way I always do this is I write my p-value, 0.0913. And I write my alpha over here, 0.05. And I figure out which one's bigger. Well, 0.09 is bigger than 0.05. 9 is bigger than 5. All right, now I also have a silly song I created to try to help everybody remember. Here's the song. If P is less than alpha, reject the null. If P is less than alpha, reject the null. If P is less than alpha, we reject the null. If P is less than alpha, reject the null. Okay, so silly little song. We have, if I read this, P greater than alpha, so it's not less than, can't reject, do not reject the null. So that is what you say in step 4, do not reject the null. P is greater than my level of significance, therefore do not reject the null. If we do not reject null, then we say there is not enough evidence at our level of significance, 0.05, to conclude the proportion of subjects taking Humira who experience nausea is in fact greater than 0.08. Every single time we do this, we're going to follow the same exact process. Which do you think is easier to raise, a boy or a girl? When asked this question in 1947, 24% of all Americans said raising a girl was easier. This is what we have. This is our status quo back from 1947. In June 2018, the Gallup organization surveyed 1,500 adult Americans, of which 408 felt it was easier to raise a girl. This is our study info. And here's our question. Does the result suggest the proportion of adult Americans who believe it is easier to raise a girl has changed? Okay, they didn't say is greater or is less than. It says has changed. Has changed implies not equal to. You're always going to want to pick those three things out. What is your status quo? What is your survey info? And what is your claim? Or what are we trying to test here? We are going to create our hypotheses. Our status quo is 0.24. That is what we knew before. What are we testing? Testing that it is different. Different means it can be higher or it could be lower. I'm not testing one way or the other, just that it is not equal to. Step 2, we are just going to verify that sure it is a random sample, which it said. We could do NP times 1 minus P, it's going to work. And yes, our sample is less than 5% of the American population. Again, just check it off. Okay, I promise they will work. Every question I give you, this will work. Next question then is go to StatCrunch. So we are working with the proportion. I'm going to go to proportion stats. I have a sample and I have a summary. From my results here, we had 408 out of 1,500. I want to perform a hypothesis test against the value 0.24 and not equal to 0.24. I entered my level of significance and I'm just going to click to show the critical value. You may be asked in your homework, what's the critical value or what's the Z stat? So this table will then spit all of those out for you. It asks you for the Z stat. You've got it here. What's your critical score? That's here. And then this is our P value. So what we do with the technology is get the P value. So on the next slide, you'll see my screen. Using technology here, I'm not doing by hand, which we don't do. So P value is right here, 0.0037. We compare P value 0.0037 to alpha 0.05. So I work piece by piece. 0 and 0 are the same. 0 and 5, 0 is smaller. So I read this as P is less than alpha. When P is less than alpha, we reject the null. Reject the null. And if we reject the null, we have enough evidence to claim the proportion of adult Americans who believe it's easier to raise a girl has changed. This level of significance, 0.05, means that we can be 95% confident in our results. How did this relate? Well, this relates to what we just did in chapter 3. I could use a 95% confidence interval to compare the results here. So A 95% confidence interval for the proportion of adult Americans who believe it's easier to raise a girl would be between 0.249 and 0.295. So my 95% CI is 0.249 to 0.295. Our original value was 0.24. Oops, I went the wrong way. Our status quo was 0.24, and that is outside of this interval. Based on our results say that, hey, the proportion should be between 0.249 and 0.295. It does not include my original proportion of 0.240. 0.240 is smaller than 0.249. It's not included in here. So just to kind of think about it here, if you had this on a scale of 0.24, 0.25, 0.26, 0.27, 0.28, 0.29, and 0.30. Okay, this was our status quo. And our study said that it's between 0.249 and 0.295. So this is what our study says. Our status quo is outside of that value. So we now have enough evidence to claim that it is truly different than what we had before. Really, confidence intervals and hypothesis tests go together. You can use one method over or the other one to be able to do the same process. Most of the time, I just follow the hypothesis test, but you can use the confidence interval as well. In 1994, 52% of parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 256 out of 800 parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did in 1994? Use alpha 0.05 level of significance. Always going to start with our two hypotheses. Our hypothesis is 0.52. That is what we know to be true from previous research, 0.52. We want to know if they feel different today. Different implies not equals to. Then I'm going to write down my information. So my survey information is 256 out of 800 with an alpha level of 0.05. I'm going to open up my StatCrunch and I'm going to enter all my information. Proportion test, one sample, summary. All right, I'm going to make this a little smaller so I can see what I wrote over there. 0.52 doesn't equal 0.52. We had 256 out of 800. We are still using 0.05, and then we're going to compute. What we need to write down then is our p-value. So p-value 0.0001. And compare that to alpha of 0.05. So 0, 0 the same, 0, 5, 0 is smaller. If p is less than alpha, reject the null. Okay, p is less than alpha, so we are going to reject the null. And if we reject the null, we have enough evidence to claim the proportion of parents with children in high school who feel it is, I'm trying to think of a way to shorten this, who feel not enough math and science is taught is in fact different from 0.52. Okay, and here, the one other thing I want you to look at here is in your test here. So my proportion based on my sample information was 0.32. What I knew before was 52% thought it was not being taught enough. This sample says 32%. That's a really big difference. 52 to 32% is a pretty large difference that happened, which is why we have enough evidence to say here that, yeah, this is really different than what we had before. So if these two values were really close, like 0.52 and 0.503, that's probably not going to be enough to claim a difference. You should be able to see that, yeah, these are distinctly different than the other one, or one is distinctly higher or smaller than the other. All right, another one. For fatal traffic accidents. According to the National Highway and Traffic Safety Administration, the proportion of fatal traffic accidents in the United States in which the driver had a positive blood alcohol concentration is 0.36. Giveaway, write it down. P equals 0.036. That's what I know. Suppose a random sample of 105 traffic fatalities in the state of Hawaii results in 51 that involved a positive BAC. Does the sample evidence suggest that Hawaii has a higher proportion? So proportion greater than 0.36 is my alternate. I write my information. I had 51 out of 105 with an alpha of 0.05. Most of the time, your alpha is going to be 0.05 unless they tell you otherwise. We got to calculate our p-value and compare that to alpha. So alpha 0.05, let's get our p-value. Okay, so stat, we're doing proportions, one sample, a summary. All right, we had, make sure I get the right number here, 51 out of 105. We've got 0.36, and we want to know if it's bigger than 0.36. I click to show those and click compute. Okay. So our status quo value is 0.36. This sample proportion is 0.48 or almost 0.49. 36 compared to 49%. I'm going to say that's pretty different. And now we can check that by our p-value here. Our p-value is 0.0036. So 0 and 0, same. 0, 5, 0 is smaller. All right, p is less than alpha. We reject the null. If we reject the null, we have enough evidence to claim the proportion of traffic fatalities in Hawaii with a positive blood alcohol concentration is in fact greater than 0.36. Got one more example, and I'm going to show you how you could use a confidence interval to check the same thing. Detailed hypothesis testing using confidence intervals. When testing, so note this will work for equals versus not equals. If the confidence interval contains the initial value, we do not reject the null. However, if the confidence interval does not contain our status quo value, we can claim our claim. We're going to use the confidence interval to test the same thing here. So a 2009 study by Princeton Survey Research Associates International found that 34% of teenagers text while driving. So there's our status quo. P equals 0.34. As a recent survey conducted by Consumer Reports, which found 353 out of 1,200 randomly selected teens had texted while driving, suggests that the proportion of teens who text while driving has changed. So we're checking, has it changed? Is it different than that 0.34? And we're going to use a 95% confidence interval. So 95% CI is the same as an alpha of 0.05. 95% confident, alpha is 0.05. They go together. A 90% confidence interval is a 10% alpha. Let's get our StatConf open here. So same place, proportion stats, one sample, summary. All right, in this one we have, what did we say? 353 out of 1,200. And this time, so if you want, I'm going to show you both ways here. So 0.34, not less than 0.34. Instead, though, first I'm going to do my confidence interval. First, doing the confidence interval, here's what I have. The confidence interval goes between, I'm going to write this down here, 0.268 and 0.320. This is where it's saying it will fall based on our survey. Status quo was 0.34. Is 0.34 inside of here? No, 0.34 is outside. What we have here is we have enough evidence to make our claim that it is now, in fact, different. If you didn't understand that, you could go back and just click the options, edit button, and instead click the hypothesis test and check it that way. So p-value 0.0008. 0.0008 is in fact smaller than 0.05, so we would reject the null here. They work together. In a not equals to, we check to see if our status quo value is inside of our CI. If it is, we can't reject. If it's not, we can. So same thing here, it proves that we have a small enough probability value that we can reject the null. Because 0.34 is not within the bounds of the confidence interval, there is sufficient evidence to conclude the proportion of teens who text while driving has in fact changed. That is our test with proportions. So the next thing we're going to do is test means and then standard deviations. So I'll see you back.